Going on? Today, I'm going to watch some systems design interview videos. Probably review this book, Designing Data-Intensive Applications. I listened to it as an audiobook. Consequently, didn't learn that much. But let me get the light counter on. Counter clicker. And consequently, didn't learn that much. Because, dude, oh my god. Because I don't know. This book, I think it's so hard not to say bro. I think it made me more aware I know certain things exist and that if I heard them by name, I could learn what they are faster than I could before. But I can't actually recall from no information when to use a certain type of database or how a certain database sharding tactic works or how a certain server database leader promotion algorithm works. So I need to review the chapters. And then I'll also work on this Gleam issue I was. I'm gonna get something to eat and find a video. Na YouTube. Shout out what I looked up, what me and my roommates looked up in the last 2 weeks. What was it about systems design? Hoje é o vídeo. I'm not trying to watch a clickbait. Don't panic. Easy enough. Understand that. Red flag. Play the game. That's certainly cringe at best. You communicate, yeah, easy. You find yourself pushing back. That's quite a blunder. I mean, okay, this is useless. Okay, I occasionally do this. God forbid a man think, bro. Yeah. So I think if I just Yeah, I just wanted examples, bro. Twitter? Sure, let's do Twitter. Alright. One sec, let me cook my grub. Just make the Kroger screen the I'm going elsewhere screen. Huh? I already paid for leak code, bro. Why y'all trying to make me buy something else? Yeah, I mean, I think this is easy, honestly. And this is like the same thing the YouTube one had. You haven't like to publish the I'll watch this part. I just realized the sound's probably not on.
Of 500 million are
Rip.
actually active, it makes sense to generate the news feed for all of them. Even if 60% of them aren't going to actually view it, it's not a ton of wasted work. And we could also tune it such that we only pre-generate the news feed for people that are actually active within the last 30 days. Now, at a very high level, what we can do is have some kind of message queue or pub sub system, which will take every new tweet that is created, will also not just be written to the database, but it will be sent from the app servers to the pub sub queue. And this queue will feed into a cluster, something like a Spark cluster. But the point is that these workers will in parallel process all the messages that we're getting, which will include every time there's a new tweet that is generated. There could be a lot, so we need to do this asynchronously. And the point of this is that these will basically feed into a new cache, and this cache will be responsible for actually storing the user feed. So now when a user loads their homepage and gets their list of 20 tweets, the application server will actually be hitting this feed cache. Maybe this cache is used for individual tweets that are maybe embedded on websites, or sometimes you just open up an individual tweet, not in the context of a user feed, and you want to maybe look at the replies of that tweet. But this is starting to make a little bit less sense, even having this cache. So I'm just kind of giving some possible use cases. But this is the cache that will actually have a feed for every single user. So if this is in memory, it may have a large amount of data. Now we have 200 million users, and if we want to have 100 tweets for every single user, it could be a very large amount. So we probably want to shard this similar to how we did with our relational database. But the point is that this will definitely lower the latency, because the feeds are not generated as a user actually requests to actually get the feed. We don't have to actually run a complex query on our relational database, having to query multiple shards and then joining the results together based on the time that they were created and then ordering them like that. The feed will actually already be created. Now, the complicated part is actually updating the tweet. We kind of went through the flow of when a tweet is created, it will be added to the message queue. And then for that individual tweet, these workers will add that tweet to all the feeds of people that are following the author of that tweet. But now the problem is, if somebody has 100 followers, then these workers will have to update 100 feeds. But what about somebody like Kim Kardashian, who has maybe 100 million followers? Updating 100 million feeds every single time somebody popular like that makes a tweet is very, very expensive. Maybe in that case, it's not the end of the world for us to actually have to update the feed of that user at the time that they actually request it. Because somebody could have 100 million followers, and us having to update 100 million feeds every time they make a tweet is pretty expensive. But not all 100 million of those followers are even loading their feed every single day, so it'd probably be easier to do that work as it's needed. So when a user makes a request, they get their feed, but maybe in parallel to that, our app server could look for other tweets. Probably a popular tweet by somebody like that is already cached here. So then at that point, our application server would also update the feed of that user. Now, what gets even more complicated is what happens when a user follows somebody new. Their feed has to be updated in that case as well. Now, it's okay. We can tolerate a few seconds, maybe 5 or 10 seconds before their feed is actually updated, but it does have to get updated nonetheless. And we would have sort of a similar mechanism where a user follows somebody new. We add a message to a message queue. We have a bunch of workers that then have to update the feed cache of the person who just followed somebody else. And by the way, this cluster, of course, is going to actually have to read our database as well, which actually has the tweets themselves. Remember, the whole point of doing this is to lower the latency. When somebody opens up their homepage and they want to see 20 tweets, we want it to be as quick as possible. And all this complexity arises from that. If we can tolerate a few more seconds, we can simplify our design. But as long as this discussion has already been, I want to say that all of this has actually been pretty high level. Things can get much more complicated, and this is actually definitely not exactly how Twitter is designed. There are actually problems with this design as well. There could be concurrent updates to our cache. There's a lot of details that we haven't discussed. How would the ordering of the feed even be in this case? When somebody loads 20 tweets, they want to see 20 more. We obviously have to paginate that, and there's a ton more details that we could have gone into. The main takeaway though here is that Twitter definitely cannot be designed or built in a weekend. Designing these large-scale systems is a very complicated task. Even engineers who worked at Twitter for years still ran into issues where they had to modify designs. And if you read some of the white papers from 2010 up until now, they actually did. They changed parts of their database, how they were storing relations, how they were storing who follows who. So with that, I encourage you to read some of the official papers that the engineering teams at Twitter have written if you'd like to learn more, because while things can get complicated, they are still pretty interesting.
Try this one out. All right. So we have cars. I'm gonna compress them. So, all right. Empty string S. For each group of consecutive repeating characters, it's one append. Otherwise, append the character followed by the. Excuse me. A2, B2, C3, A1. So you do each character. Why is this 1? Okay, it's 12. 1, 2. All right. So the intuition for me here, start a first car, eat an increment. So like we'll have a scope where we're eat an inc. Returning an I-32? I thought it was a... Okay, wait, what are we returning? Oh, okay, so it wants it in place. Okay, that changes things. And return the new length. Okay, so that, yeah, that makes it more difficult. So you're at a character. So this is shorter. So how does that work? Okay, because it's a back. All right. So back here. So I need to recall how this works. I'm gonna want the index as well. I think I'm gonna need iter mute. Iter mute. So imagine we're at 4 C in cars dot iter mute. We're gonna need some kind of external state. So I kind of need two indices. One is the right index. Size. What is the index type? U size. That's for a slice. This is not a slice. Should be fine though. Apple AirTag false positive rate. I would only get like one a week because I live in an apartment building. It's so annoying. Until I'm actually getting tracked and then I'm like murdered and it's like, that was unfortunate. So say I'm going through this. Well, like a current character count. So you have A, and then in this case it's 1. Okay, it starts at 1. So the current character. I have a U size CCC, current character count, on the right index. So here, 1, 2. We're not going to know until we're here Hmm. We're not gonna know until the next character that we need to write 2 to the previous position. The length of the array is gonna shorten a lot. AB12. And you don't know until you're at the end. Excuse me. Here we're at A. So you start at 1. B. Looking at C, make this 2. It'd be smarter to start from the back. C, 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 B, and then you gotta write 2. That doesn't really help anything. It's only when you look at B that you know to write 2 in the previous position. And that's when you increment the right index. So the right index is going to be 1 for each, you're incrementing it once for each character and once for each digit base 10 of the count. And ants, usize ants. Or we can just, or does that only go, you can just do use, or sorry, at 32 ants is 0 as well. We'd have this iter mute. We need to be able to index this better. So we're going to need to go back. Okay. So if I'm in the iter mute, it's going to be hard to go back to the previous one. That's the problem, I believe. So instead, let's do cars.size. And I want to index. Yeah, the problem is I want this in less of a Vecchi way, bro. Dude, an AIDS. Oh my gosh. I'm cooked, bro. Not size. My old. Dude, I'm so washed. I just want to see style. So that's some progress. So, in the case that next car neck, what are we doing? Four digit. What do we do in this case? So the right index will start at 1. Right num digit by digit right index. Skip 1, set prev. Or if there's only one of a character, you do A1 or wrong tab. The one of a character, you just do A. Okay, or that's better. So you'll start here. Next character doesn't equal it. If CNP equals 1. Dude, what am I pressing right now? 1, just jump. So we're really looking at if cars at I is equal to prev. CNT plus equals 1. Continue a keyword. Yes. So here it's not the same. So what do we do? So we need a little loop to write the count as a string. And we'll make it generic. So while CNT, while the CNT is what? Greater than or equal to 10. Do greater than 9, I think is better there. Cars. So popped is equal to, sorry, let popped is equal to CNT slash 10. You're gonna have to look at it as a string anyways. Yeah, you're gonna have to look at it as a string in anyways, so I don't even think trying to do this tactic can help you. So before you do this, you actually got to set the right index to 0. Then we're gonna overwrite the first character with prev. So here we're gonna say cars at right index is equal to prev. And then here's where we do this. Cars at right index. We can do plus plus here. I don't think Rust has plus plus actually. Yeah. Cars at right index equals C. And we'll do right index plus equals 1. The right index is just 0. So yeah, and here we gotta do this here as well. If CNT is greater than 1, you do this. Gotta go to the bathroom real quick. Stack as well. All right. Yeah, bite. How would the index ever be that large? Let's see. Right index is 0, writing the previous character, that's A. Also here, after we do this, we need to set prev is equal to so we're kind of going retroactively. Yeah. So this is when we're on B. So we just skip this. Do I plus equals 1. Got an open mic, man. One second. So why are we overflowing here? Let's look at this. Pre for starting at 1. Count. Cares if I equals pre for start at 1. It's equal to pre. Continue. So now we're at B. B does not equal pre, so we're here. Cars of right index, which is 0, is equal to pre. Right index plus equals 1, so this is now 1. Count. So count should be 1. Right index is getting too big. This should be A2, B2, C3. So I don't really understand how we're overflowing. Make this back to 0. Kind of interesting here. Hmm. For cares 1. 1. So this should be 1. Count 2-string cars. Let's print line. Count here. We're gonna have to do this. We can just print the C. I'm calling this 4 times. Huh. This car is returned. Maybe we need to do as stir here. Might be not the right type for that. Yeah. Let's see. Can you do it there? Nah. Excuse me. Excuse me. Bit confused why we're going so many iterations when it's 2. Count of A is 2, that's correct. Now, why is this so long? Why is there so many loops, dude? See? Oh, it's not. It's only looping once, but this whole thing is looping many times. It's because we're not resetting count. After this, you do I plus equals 1, you do count equals 1, and you do prev equals cars of I. Now we're missing C3. We missed the last one. So, well, I think the easiest case is why are we missing this case? Prev is 0. Prev is 0. Count 1, right index 0. Index 1 is just out of bounds from the jump. So what's print line here? Does this get the, for instance, in this case, does this know that prev is C? Let's see. We should actually just be doing debug here. Did they not set it up to print debug? Right. So having this, using LeetCode makes me remember how annoying not using Vim is. Where's my original? Oh my god, dude. Why is there a command to open up Google Chrome Help, bro? That is so useless. So it knows that. Does it know the count? It knows the count as well. That's clutch. So we just need to have a thing here at the end. Maybe this should be chars 1 plus 1. Will that fix it? No, because the right index is out of bounds. So just here, there's probably a cleaner way to do it, but you can effectively just do this. Thought I was smooth with it, but we're missing some cases here. Oh, so when it needs to be longer, it doesn't work. Let's look at this. A. So we're starting at B. So I think this should be like peek, look ahead instead of look back. Hmm. So instead of having pre, we'll have next. Start at A. Look to the next one. So it actually should be 1. Look to A, look to the next one. We're not incrementing it. So what do we do? Cars at right index. This is equal to cars at I. Increment right index. If the count is greater than 1, do this. Then don't do this. Oh yeah, what am I doing? Cars of I plus 1. Huh? Tell me that debugging wasn't goated. That was some of like the quickest debugging I've ever done. Low-key. Just changing it from uh slow to changing it from like previous to next. Nah, I'm low-key goated, bro. I'm actually kind of proud of that. Little self-glaze. Is that the first raw solution? Nope. Then why did it say it was... Oh, because they all use 0 milliseconds. So let's see what some other people did. Just treating it as a splice. Honestly, I don't like that. I'm curious if it's faster. What are these guys doing? Two pointers. He's got a flat, fast, and a slow. This is clean. Yeah, this is what I did. So I kind of prefer, I mean, obviously because I wrote this, but I kind of prefer having your primary iterator and then calling the other one a right index. I guess, I mean, that's just semantics, but next as underscore. Oh, is that a, that's kind of smart. That's solid, actually. All right. So That's that. I'm chilling. I'm trying to consider what I want to do now. Maybe Gleam. Dude, also my phone isn't charging. Like, what is going on right now, man? Switched over here. Maybe another one. Let me check this. All right, so I need to learn what some of these things are. What is NVIDIA Omniverse? Let's look it up on YouTube because I have no attention span. Excuse me. Is that Halo? That's gotta be Halo, bro. For real. kind of dope. Dude, if I get this, that's gonna be freaking insane. In what, homie? Let's go to NVIDIA modules. Bro, y'all gotta get better mics, bro. Come on. That's kind of goated, actually. Bro, this is kind of crazy, dude. Kind of wild, bro. That would be dope. Bro, not the AI cat, bro. Come on, bro. Come on, bro. So I couldn't tell you anything about the AI shark. Это на гитву. О, ебать! Ебать! Nah, being able to use the personal GitHub, that's goated. That's goated, dude. That's actually super cool, man. That's crazy, dude. That's actually wild, man. Having the personal GitHub, that's crazy, bro. That's really cool. Yeah, I obviously wouldn't work on this. I don't know anything about machine learning, but that's really dope. Yeah, I know nothing of this. Huh. I might look. The thing is like distributed systems could be this. What's this here? This is PyTorch. I don't think this would be PyTorch person. Oh, I thought that's a Axie. So next, what is NGCSW? NGC, HPC. I'm really surprised those were suggested for this. Because, like, I am not a HPC nor AI type of person, bro. So I think they looked at me because I'd use Kubernetes, but I mean, that doesn't really mean anything. Just talking about device plugins in the NVIDIA GPU operator. So I would probably be on this. This is like closer to what I was hearing, I believe. So I might do some more leak code in Golang. So I did that'd probably be the easiest. I mean C, Rust. I know a lot of Rust, like some of the iterator functions. And there's just more types as well. Um, let's look at NVIDIA Cloud Functions as well. Let's go to the NVIDIA portal with gRPC. Oh, I'll probably watch a video on Kubernetes device plugins. Let me see my Kubernetes book.
they can't both be scheduled on that same machine. It only has one GPU. So the scheduler needs to understand the resource of the GPU. And this is where device plugins come into play. But this doesn't really, device plugins itself doesn't really solve the entire problem, because not only do you need to be able to schedule it, but you need to install the drivers, because the NVIDIA drivers need to be installed on that node. And then not only do you need to be able to install the drivers, but classically this needs to be done in the container. And that's only the start of your problems. Which nodes do you do this on? How do you know if there's a GPU? So very easily, the way you would do this manually, and I don't recommend the manual process except as a learning experience. And there are some slight edge cases where you would not want to use the GPU operator. Yeah, you wouldn't want to use it, because if the node doesn't have access to the GPU anymore, and if that's a requirement, or if you're using multiple management styles, so it's not just Kubernetes managing the node, this could cause problems and a reason why you wouldn't want to use it. But I think you want to use it unless if you absolutely can't. Anyhow, if you wanted to do it in a classical sense, you would, for your distribution, install whatever NVIDIA drivers are supported for your system, hopefully the latest CUDA drivers possible. And after you were done installing that, you would need to then expose that to a container that was running, and you could use the OCI hooks for cryo, and you could use, you could just start up the NVIDIA container with the correct proper Docker command if you're using Docker or containerd, and that would work fairly well, but it comes at a cost. You have to start containers with special flags, or you have to install the OCI hooks on every single machine with GPUs. And the last thing is you have to install and manage the NVIDIA drivers on every single machine. This is a huge overhead. So this is where the GPU operator comes into play, and it does some things a little bit differently, and it does some things in an interesting way that you might not expect, because in the end, the drivers don't actually ever get installed on the node. So the first thing that you have to understand is daemon sets. And again, this is something I've been wanting to make a video on, and I will make a video on. But daemon sets are, think of it as a pod that's run on every machine. It's almost like a static pod manifest, but it can be controlled by the daemon set controller. Whereas a static pod manifest can't actually be controlled. It's just files written to a fancy folder, not even a fancy directory. It's just a directory. You write a file to it and it will make a pod off of it. So daemon sets don't have to run on every node. Classically, they run on every single node, but they don't have to be. That's key to keep in mind when thinking about how this all works. But the GPU operator does a couple things. First, when a node joins, it joins the cluster, or when you first install it, and it does this on each node, it installs a first daemon set. And this one actually gets installed on every single one. So the first daemon set, what it does is it basically goes through and labels nodes that it finds GPU hardware on. So it uses the PCI and it finds GPUs. Once it finds all the GPUs, it labels those nodes. So it says this node has a GPU and it puts a label. It puts this label. The next thing that it does, and this is really where the magic comes into play, is it, on every node that it has labeled, on every node that's labeled, it installs another daemon set. Now, it only installs this daemon set on nodes with the label. And this is the driver daemon set. And this is really the cool thing, is their drivers are in a container. And now, exactly how this works, I don't know, because this code is not open source and I don't work for NVIDIA. So I can't actually explain exactly how this works. I can go into some videos on how it can work, and some of it's like the OCI hooks. And I'm assuming they do something like that. And I think that it would be a fun, maybe even series of videos to do something like this ourselves, maybe with some open source drivers. So, anyways, but I can't tell you exactly how they do it. I can only speculate. So, that is the second container. It's a driver container that exposes the drivers to all the other containers running on that node. And that's pretty much it. The second or the third daemon set that's installed is just the device drivers. So the device plugin, the Kubernetes device plugin, and that allows those nodes to be scheduled as GPUs. Or a node could have 4 GPUs, and it would have the device plugin would say, I have 4. So now it knows that node A has 4 Tesla T4s that it can schedule. So this is the very basics of the GPU operator. And it does this for every node that joins and leaves the cluster. It's a fairly simple but advanced solution to the issue. And this allows you to not worry about your hardware that's running in your Kubernetes cluster. You can add and scale clusters of GPUs quickly and easily without a whole lot of management of it. This also allows you to keep your drivers up to date with the most securest ones easily without needing to actually go to the machine. I actually think that this is the new way of doing drivers in your Kubernetes cluster because it allows you to containerize your drivers and provide it in a way that can be updated and managed at a Kubernetes level. No longer do you need a separate way to manage drivers for your cluster because it's right there. Now, obviously, there are base packages installed in your OS, and I'm not saying all of that goes away, but maybe some more drivers like GPUs can be done in a way like this and would reduce some of that overhead. Anyways, I just thought that this was an interesting topic, would be great for a Mighty Mini Monday on Tuesday. And I hope that all of you have a fantastic rest of your week. If you liked this video, please give it a thumbs up and subscribe. And if you really didn't like this video, go ahead and hit that subscribe button and stick around and see if these videos get any better for science.
I'm Chris Parsons, one of the lead product managers for NGC at NVIDIA. Today, we're going to show you a demo of NGC Collections in action. With this new feature on the NGC catalog, we're simplifying and accelerating your end-to-end AI workflows. AI workflows are extremely complex. From extracting raw data to deployment, it takes a team of people. Additionally, the applications and tools needed to build an end-to-end AI solution are complex as well. No AI deployment is simply just a container or just some pre-trained weights or just a Helm chart. AI apps are a combination of all of these things and many other components that are essential to getting the job done. With NGC Collections, we put all the assets you need in one place. You no longer need to search for and evaluate different containers, deep learning models, and even code samples. You'll find it all here. We've got collections for everything from recommender systems to object detection, and even your favorite NVIDIA deep learning apps like transfer learning toolkits or NeMo. For every asset on NGC, we also show you related collections so you can discover new content, models, and software to make your workflow easier. To get started, you just have to find the collection for your use case, download a container and model, retrain and optimize the weights with your data, and then deploy the app as an API so you can use it wherever you need. To show you how easy it is, we built this example Jupyter notebook to build an app for face mask detection. Now, Adel Al-Halak, NGC's Director of Product Management, will show you what we built using just 4,000 publicly available images and 2 hours of training on a single NVIDIA V100 Tensor Core GPU.
Thanks, Chris. So now we have a live stream feeding our face mask detection model deployed with DeepStream. This is a snippet of Talia and I taking turns putting masks on and off. As you can see, the model is quite accurate for one that has only been trained for a couple of hours. Hopefully you appreciate how easy we're making it to build an end-to-end workflow for a face mask detection use case using the transfer learning collection from the NGC catalog.
Jumpstart your AI workflows today with NGC Collections. Head over to ngc.nvidia.com to get started.
Waking up and just going to work and working on this type of stuff is kind of crazy. I've been streaming for 2 hours. Get my book. We've got clustered networking, overlay networks. So I'm on now. Next is service and ingress networks. When things go wrong, this is on scheduling. Insufficient resources. Pulling images. Running containers, debugging logs. Port forwarding. Then we have control plane and access control. API server auth. Bootstrap tokens and service accounts. Container runtime. So this is more about like the lower level things of Kubernetes, it appears. Maybe not even. I don't know. I'm on can already do something through the book. You got health probes. So this is like more using. Yeah, this doesn't really teach you this stuff we're talking about right here. That appears. And we have a section on performant Kubernetes. Affinity in devices, tuning quality of service, and resiliency. All right. So I'll still probably try to read that in the next few days, but that's not really too useful here.
In this video, we're going to talk about what Kubernetes operator is, why did
Hi everyone, my name is Cy Venom and I'm with the IBM Cloud team. Today we want to talk about operators. And no, I'm not actually talking about operations teams, but instead the operators framework which can be used on Kubernetes or OpenShift. CoreOS actually introduced the operator framework back in 2016. CoreOS is now part of Red Hat and IBM. Operator framework is quickly picking up traction as it's a great way of managing complex Kubernetes applications. Now, before I jump into this, we want to actually introduce what the Kubernetes control loop is, because that's a core part of the operators framework. In this video, we're going to be talking about things like deployments and pods. So if you're not familiar with those, be sure to check out the Kubernetes explained video that I've done on those topics. But let's get started with exactly what the control loop is in Kubernetes. Now, essentially, the way it starts, the control loop, is a core part of Kubernetes. It observes the state of what's in your actual cluster. So that's the first step, observe. Next, what it's going to do, Kubernetes, is going to double check that the state in the actual cluster versus the state that you want it to be. So it's going to do a diff. And finally, it wants to resolve that diff by acting on it. So the last phase of the control loop is act. Now the control loop is core to how Kubernetes works, and there's a controller that basically acts on that for every default resource. Kubernetes comes with a number of default resources. Let's see an example of deploying an application without operators using these default resources. So as an end user, essentially, the first thing you're going to want to do is write up some YAML, right? The spec for that actual application. And for our particular example, let's say that we're doing a deployment. And in this deployment, we'll have to define some configuration, things like what's the image, and maybe the replicas, and maybe some other configuration. So that's one Kubernetes resource. And essentially what you would do is take that and deploy it into your Kubernetes cluster, at which point a deployment is made. Here's where the control loop kicks in. So Kubernetes observes the state of your cluster. So we've got our Kubernetes cluster here, and checks what's the difference between what you want versus what's there. First thing it notices, there's no pods. So it's going to act on that difference, and it's going to create some pods. Now, let's say for a fairly complex application, we don't just have one YAML, but we have a second YAML. Maybe it's for the back end. And so that deploys a second deployment. And that, in turn, deploys a pod using the controllers and the control loop. Now, it's a simple example, but say you want to go through here, scale up the application, make some changes, set up some secrets, environment variables. Every single time, you have to either create new Kubernetes resources or go in here and edit the existing ones. That can start to get fairly difficult. Now, let's see how that's done in a world where we're using operators. Now, the first thing you would actually need to do is install the operator itself. So someone in your team has to create the operator, or maybe you can use one of the many that are out there on Operator Hub, where the community is building on the operators that are available. So the first thing you need in your Kubernetes cluster is the OLM, which is the operator lifecycle manager, which basically manages the operators that you have installed. Next, you deploy your actual operator into the cluster. The operator is made up of two major components. The first component in an operator is going to be the CRD. The other one is going to be the controller. Now, the CRD is basically a custom resource definition. So we've talked about default resources, things like deployments and pods. A custom resource is something that you define as a user in Kubernetes, or maybe an operator defines it, so that you can create YAML to work against that custom config. The controller is basically a custom control loop which runs as a pod in your cluster and runs this control loop against your custom resource definition. So let's say that an operator is created for our custom application deployment here. So instead of having to write multiple deployments and setting up config maps and secrets for whatever our cluster needs, we instead, as an end user here, will instead actually just deploy one YAML. Maybe we called this operator my app. We could be a little bit more meaningful here. We could call it stateful app, front-end app, whatever we want it to be. And then we could define some config here, or we can use the defaults that are set. You kind of have a choice of options here. Then we take this operator and we deploy it directly into the cluster. At this point, the operator takes over, and this is actually responsible for running that control loop and figuring out exactly what needs to be running. So it's going to realize that we need a couple of deployments and the pods. Now, this is a kind of a format or approach to managing
Yeah, I like this. I
applications
used to watch
that's
like
inherently easier and scales
AP
better
physics
than
videos
this
from a
approach.
dude that
Because as an end user,
did this
you really only
mirror
have to worry
tactic,
about the
or the
config that's been
class
exposed to you, and the operator itself manages the control loop and the state of the application, how it needs to look. Now, there's great operators out there already, things like managing etcd or various databases, or even IBM Cloud Services. So all of those operators currently exist on Operator Hub.
Понятно.
But say you
Я
want to develop
понимаю.
your own, maybe a custom operator
Я
for something
вижу.
that is native to your application architecture. Kind of like what we sketched out here.
Такой Helm.
Well, there's a number of ways you can do that. And there's something called the Operator SDK that allows you to start building out operators yourself.
Let's do another one of these.
Now, I'd say the easiest way to get started with an operator is to use the Helm one. So,
Shout out Helm.
as you may already know, there is a video where David Okun goes over exactly how Helm works. Be sure to check that one out. But the Helm approach allows you to take a Helm chart and apply that towards an operator, expose config. So it allows you to get to a fairly mature level of an operator, kind of something like this for a chart that's already there. Now, the maturity of operators, what I've sketched out down here, falls into 5 different levels. Now, Helm actually hits the first 2 levels of maturity. Let's talk about what those levels are. The first one is basic install. Essentially, the first level is basically going to allow you to do just provisioning of the resources required. Now, the second phase goes a little bit further. It's going to allow you to do upgrades. So this supports minor and patch version upgrades to whatever is defined in your operator. Now, Helm gets you that far. What about for the next 3 levels of maturity? For these, you're going to want to use either Go, or you can also use Ansible. Now, these will allow you to actually get to all 5 levels of maturity.
Go or Ansible.
With
Go is in the
operators.
programming language.
Let's quickly talk about what those are. At the 3rd level,
Just
we've got
Ansible.
full lifecycle support. So this is storage lifecycle, app lifecycle. It's also going to allow you to do things like backup and failure recovery. So that's something that would be
So I guess it
kind
is
of
Go.
configured and developed into the operator, whoever developed that one. 4th, what we've got here is insights. This is going to allow you to get deep metrics and analysis,
That little thing with
logging,
the-
that kind of thing from your actual operator.
Like he writes and
Finally,
then it like increases in
What we
saturation
have is
afterwards.
something
It's kind of
called
dope.
autopilot. And just kind of how it sounds this is going to have a lot more functionality
The
built
heck?
into
How's that
operator
possible?
itself. Basically, it's going to allow you to do automatic scaling, horizontal
Wait, that's
and
actually
vertically.
wild. What is that?
It's going to do automatic.
Like he
This is
writes in
going to
its
have
goal,
a lot more functionality built
and then
into
the
operator
saturation,
itself.
or perhaps like
Basically,
the
it's going to allow
value.
you to do automatic scaling,
Better
horizontal
the
and
value,
vertically.
so,
It's
like
going to do automatic
increase as he
config
finishes
tuning.
the
If
word.
your operator-based app gets into a bad state, it's going to identify that automatically. So these are kind of the 5 levels of maturity that operators can have. By looking on Operator Hub, you can see the ones that the community has developed and see what level of maturity that they hit. And then again, by using the Operator
See, I'm
SDK,
still a bit confused. Like, say you have a deployment. Won't Kubernetes still recognize if your pod, like, say this deployment has this pod, like,
you can build your
it'll still observe
own
if the pod
operators
is like
using
down or
either
something,
Helm,
and then
Go, or Ansible.
send it again, yeah,
Thanks for joining.
or reboot it, yeah. So here
Build
you have a CRD. Yeah, I probably need to watch another one on that. Excuse me. Well, let's try to go in here and do one of these. Minimum path sum. Give it an MXM grid, non-negative. Find a path from top left to bottom right. Minimizing the sum of all numbers. Top left to bottom right. Can you go diagonally? Down or right? So this is don't you just compare each one and see if it's, or is it the case? This is DP. Because it could be like 3. I'm trying to consider if you can just greedily take the lowest one. No, because down. So you kind of have to compute a little further. So honestly, start, or the best path from bottom right to top left is the same as the inverse. So I'm considering some brute force tactics, though. How would you not brute force this? So at a given point, you have 2 options, right or left. Sorry, right or down. But you can't just greedily choose the lowest one. How would you do this not just brooding it, bruh? We can try not brooding it, but we can try just brooding it, but it won't work. So how would you brood this? You also need a lot of data as well, don't you? Dang, that's gonna be a ton of memory. See what kind of topics we're seeing here. So it does say dynamic programming. Dynamic programming. So the best problem is you still got to keep an array of all of them. So what is the answer? The minimum sum. That makes it a little easier. Yeah, put the minimum sum. So you can also look at this problem as you have to get one of each row and one of each column. No, because they have to connect. So you start here. You can choose this one or this one. So you could have it MIN. So when you're in here, down, and right are both crap. So you could know that you can just stop. I can't know that. I think you have to fully evaluate every one just because you never know if there was like, this was like a 500 and this was low. So I imagine we're gonna need a, what's the go? I don't remember going. Golang syntax. How do you declare a variable? Go variables. Declare variables, var. I need slices. Go 2D array. Sorry, 2D slice. So it's, we can call this BP. It's array event. Range len grid j range len grid 0. This just feels like trash. First, let's just see if this works. The cost to get to here is the min of its left and its top. So you kind of got to do the first. Yeah, so let's build that. So you have this. Or you can just go outside of the DP array. So let's talk about how we're going to make DP. So first row by first call is on 0. Start at like I plus 1, j plus 1. It's going to be the weight. It's going to be grid. Sorry, we can consider this. We can consider this n by m. Make dp n plus 1 by n plus m plus 1. N 0 or m 0 equals 0. All of those are 0. And you start from I equals 1. You start from ij equals 1, 1. You get the min of the top and the left plus grid of ij. And you return grid of n m. Sorry, n minus, no, nm. Yeah. I think that's right. Think I like that there. So how do you do this in real life? So I don't know if I want to slice. Go make two sized array. I guess it doesn't matter. 5 int. Problem is, I don't think you know that this is such a function, so this isn't known at compile time either. Let's just do it. So dp. So we don't have to actually explicitly make that size. Have dp is equal to a array int slice int. So for here we'll build n. Here we'll build m. So building n is going to be for I range len grid dp I 0 is equal to 0. Same thing here, but with j. We can call this n. Kind of the variable names are kind of trash, but when grid 0 0 j is equal to 0. Does this compile? No. So this is the go FMT. Yeah, it wouldn't compile anyways. Okay, so after that, we start range, go range. Go range with min. This is not what I said. Nums. Here we go. I need the index is the problem. So I think that's what that is. For I, n. Using n again. dp of n. Oh my gosh. Guess I like really gotta go to the bathroom. Alright, 1 sec. Oh my gosh, I've had the Kroger thing on my face the whole time. RIP. All right. We back. So I'm gonna pause this to watch something because I'm about to eat this SpongeBob. Or just read something. Nemo Bio Nemo.
Enterprises in every industry are adopting AI to deliver cutting-edge products and services, but they face many challenges. AI is hard, and AI workflows are complex. Data scientists and researchers need easy access to AI building blocks such as models and containers. Developers need tools to seamlessly integrate models into their API or service. And DevOps engineers need tools to deploy and manage these applications across a hybrid infrastructure. Which is why we built the NGC Catalog. The NGC Catalog is NVIDIA's hub for GPU-optimized AI, high-performance computing and visualization software. The catalog includes containers, deep learning models, SDKs and Helm charts to help you start building apps quickly. Packed with the latest optimizations from NVIDIA are deep learning frameworks such as TensorFlow and PyTorch get your teams up and running faster than ever before. These secure, portable and scalable containers allow your teams to build and deploy AI apps on premises with NVIDIA certified systems, in the cloud or at the edge. State-of-the-art pre-trained models are available, ranging from conversational AI to computer vision to recommender systems. You can take these models and deploy them for inference or customize them to fit your specific use case. With our industry-specific SDKs for healthcare, robotics, smart cities and more, you can easily build and deploy high-quality applications to production. Finally, the NGC Catalog offers Helm charts that let you deploy and manage your applications on Kubernetes environments. So how can all of this help you transform your business? With NGC, you can reduce costs by optimizing workflows, deliver incredible products and services faster, and decrease your overall total cost of ownership. Ready to get started? Head over to ngc.nvidia.com, or if you'd like to learn more, contact us to schedule a demo with our team.
Schedule. Let's listen to this as well.
Building AI agents that can speak is now easier than ever.
Hi, what would you like to talk about today?
Introducing conversational AI with 11 Labs. Build, test, and deploy, all in one platform for the most natural way to communicate with technology.
Hey, can I check the status of my order?
Yes, of course. Let me check for you now. Your order is due to arrive at around 2 p.m.
Building conversational AI agents used to be immensely complex and demand huge resources, but not anymore. Start building your agent by creating a voice or exploring our vast high-quality library to discover one that's perfect for your application.
Hello and welcome to DHK Online. How can I help you today?
With a wide range of the best LLMs to choose from, you can then upload your knowledge base and define the goal and personality of your agent. Or alternatively, you can integrate your own server to take full control.
Hi, this is Eric from Bound Events. How can I help?
Hey, I accidentally bought a ticket twice. Could I get a refund, please?
Sure, please read out your reference number and I can begin to process that right now.
Our system will analyze and evaluate your transcripts, providing you with valuable insights, conversation playback, and the ability to test and define success criteria. And it's all possible in 32 different languages.
Welcome to DC Medical. How can I help?
Hello,
How can I help? Welcome to DC
32 different languages.
Welcome to DC Medical. How can I help?
Hello, ¿hablas español?
Sí, por supuesto que hablo español. ¿En qué puedo ayudarle?
And best yet, effortlessly deploy your agent into websites with a single copy and paste. Or leverage our SDK for creating apps, services, or even video games. So whatever you're creating, get to production in days, not months. And all with enterprise-grade security to keep your users' data safe and secure. It's time to explore the huge potential of conversational AI with 11 Labs.
Least annoying AI commercial. I'm actually impressed. Hold on. And they still have customer support. One character per credit. Lynn. That's pretty cool.
And as for Cinderella and the prince, they lived happily ever after.
There is always more to every story. And this is a brand new way to experience it.
Wow, these guys doing
Introducing our new Gen FM
dude.
podcast feature. Say hello to your hosts.
I mean, seriously, I find Cinderella just so inspiring as a character throughout this whole book.
Yeah, I know, right? And she does it all in those tiny glass slippers. Unreal.
Now you can generate your own podcasts all at the click of a button.
All right, so let's dive into today's review topic, atomic theory.
Now this is one of my absolute favorite subjects. Where should we begin?
It's kind of good.
Choose any topic, any voices, any time.
Next, the recipe says to lay out the apple slices until the pan is full.
Ah, yes, this is a true classic of fine French cuisine.
Personalized podcasts for everyone around the world, and all in 32 different languages. Gen FM, now available in your pocket with the 11 Reader app.
Финский язык даже. Русский. That's really cool. Let's finish this. So for I, n in the range 1. This is going to be grid. 1 is going to be for j, range grid 0. 0. Actually, it'll just be this. No, range grid. So it'll be this again, actually. For this in the range of the line of grid. For this in the range of the line of grid. We want to start. So we're going to say, no, not editorial. Stop. Scroll this way. Description. Huh? Oh my god. Dude, what? Okay. So here, dp of I plus 1 is equal to dp is equal to the minimum at I plus 1, j plus 1. So to the minimum of dp of I j. So j minus 1. And then the one where you do I minus 1 j plus grid ij. And actually, this is going to be underscore I underscore j. Actually, this is just going to be j. So we return dp I plus, no, sorry, dp len grid 0. Huh? Excuse me. So we're missing something here. Grid 0, boom. dp. Yeah, it's gonna be dp at 1 at grid. And then at 1 of grid 0 like that. Huh? Int. Wait, what am I doing? J. Yeah, boys. So this has no specified length. That is a good point. Go make 2D array. Looks like we need this. dy. So I'm not really certain of the dy dx thing. There's dy here. So it looks like his dy, my dy is len grid. Dx is going to be len grid. First element grid. This is not it. First of all, this would be dp, 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 int, следующий. -1. Huh? So it looks like a range is getting exceeded here. -1. 0 minus 1. Yeah, I'm a little dumb. This should actually be +1. Yeah. Or, I guess it should be +1. Or it kind of should be -1, but ij needs to be incremented. Yeah. So actually everything else is just +1. So this is +1. This is +1. I realize I could have just not. It's just the min function. I didn't have to do that. So gridded ij in our thing. Yeah, that's right. So now we're having this error where can access 3. So this is going to be len of grid. It should be the len of grid. I'm not sure if this is like 0 indexer. So we're missing something. Can we just get submission and the problem statement on the same page? Huh? Where's the thing I just wrote? Test result is something else. Okay. So I said 3, it was 7. Do I need a +1 these? Yeah. But it's good to see that this has a length of 4. So in this case, you go right, down. Yeah. 1, 6. Huh? Oh yeah, that's expected. Well, so I missed on something here. Make the len grid +1. And you build in. So all the ends. So this should be +1 here. Zero on all the sides. Then you go in. Start into the grid. And so it's like shifted over 1. And so it's up on the J, up on the I, plus grid of ij. Huh? Why this ain't working, bruh? So it's just print. How do you print going? Need FMT. FMT to print on. FMT to print len. Yeah. Print len. Probably printf. Printf. Let's look at dp of 0, 0. Zero, that's expected. How about 0 of len grid 0? 0. Good. That DP of 1, 1. One, that's expected. Okay, so in this test case, how about 2, 2? 6, 1. So it should not be 6. We're looking at the min. Alright, so we really need to look at, so 1, 1. Oh, 1, 2. It's 3. My problem is that dumb. So, yeah, my problem is that I'm stupid. Top row, it's not that they're going to be 0. It's that they're going to be not 0. That's what they're going to be. So if you have a 0 here, it's just going to choose 0 and say it's 3, where it needs to be saying it's 1. So that's in here. So instead of making this filled with 0, I'll make it like the sum. So I have n sum 0. Let's go to n sum. N sum plus equals grid. We'll do this here. Grid of n 0. Do like the same thing down here. We can just copy this. No, that's gonna too much to change. Let's do m sum plus equals grid 0 m sum 0 m sum. One, two, three. We're not really doing that extra layer anymore. Oh my god. Yeah, I just forget how to use my keyboard. So now start putting 6. DP of 1, 2. Let's look at 0, 0. So this 0, 0 should be 1 now. Zero, 1 should be 4. 0, 2 should be 5. Okay. Let's look at 1, 1. This should be 7. 1, 1 is. So this is where we need to go. dp of I minus 1, j minus 1. dp of I plus 1, j plus 1. Yeah, this is not. It's going to be dp of I, j. Good, meta dp I minus 1, j, 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 j. So this needs to be 1, 1. Go range between 2 numbers. Huh? Alright, so we just need this classic. Index 3 at a range. Not equal to. So we're getting 7 now. Goated. Green. Green. So is there a better solution than this? Appears there might be. Let's see what it is. Dude, I hate this new thing, bruh. Oh my god. Brute force. So I didn't do that. 2D dynamic programming is what I did. One-dimensional dynamic. Overwriting it. That's smart. MN1. Doing it in place is kind of smart. Yeah, doing it in place is smarter. largely satisfied with that. Hmm. Alright, so I think what I'm gonna do now is the Gleam issue. So that's here, that's here, that's here, here. This will be the Gleam compiler. This will be the CD proj test one. And so what I leave off doing? I kind of like fell asleep as I was doing this. So we were on error, making a new error. Yeah, invalid reference to positional argument. So this should be error. I think other ones are doing this second. So yeah, and then we have dependency resolution fail. And then in here is where the locked stuff is going to be. So I'm going to pull back up the Jippity that I had. Masz Jippity. Здесь. Really tired, dude. Ooh. I'm goaded. Mm-mm-mm-mm-mm-mm. All right, so that kind of works actually. It didn't cargo format properly. Now it's just hard coded to Gleam standard lib. So it's not Gleam standard lib that's locked. It's Gleam JSON. Hmm. Problem is it's not Gleam standard lid. That's locked. It's the other one that's locked. Tired maxing. UGA fans are AIDS, bro. Half of them didn't even go there, which is the main problem. Okay, so this works. The other problem is that it's the wrong package, bro. It's not even possible. Like it doesn't resolve with standard lid. So let's go back to Rick. How do you do this again? You get a profile. I need my fork. Fork. Suggest unlock depths. That looks right. And going into resolve versions, we have the list of locked. Pass that into here. The list of locked as a reference. Immutable. Then in here, locked.contains key. Thinks that standard lib is locked. Whereas the problem is with Gleam JSON. So is it Scheiße. Let's just get all of them by doing this. So now I'm expecting just all of them. Gleam JSON. Name. Contains key. I'm surprised that the locked contains key. That implies that little odd to me. All right. Ladma. Let's see what. So locked. Scheiße! So let's just make locked conflicts, not filtered. Oh, we already did that and it was awful. So locked. Name, filter name. Iterating through the eco strings. Capturing them as name. So I'm really surprised to see this output. So this is implying that locked. So what if we just do locked? What is locked here? Locked is a hash map of eco strings. How can I turn a hash map eco string version to vec hash map? I just want this quickly so I can just paste this in, because you can't really just debug and expect that to go anywhere in this. Alright, Gypsy is scheisse. See, I think if I just do a debug, it won't actually print anywhere. Filter name is stir. Doesn't equal root name is stir. Collect packages. Solving versions. Is there like a tooltip on developing, just writing like debug? Saying that the standard lib is the problem. Ебать, зачем это не даже... Я не даже это понимаю. Ебать. Alright, let me pull up Discord and see if anybody else has talked about this issue. Discord, login, open Discord. Dang, when you look up my name, it's actually me. Oh, this is my OG Looperman account, bruh. $20K downloads. Go. Yeah, I should have bought Bitcoin when I made this. Nah, it was kind of good back then. Yeah, I did not know what normalization was. I'm a goat. Not actually. I just downloaded an ad blocker. Why am I getting all this muser? Dang, I didn't even know I was Requinton when I actually have like pretty solid SEO on my name right now. Requinton. I have like pretty good SEO. You know, that's it. Even my stream is showing up. And apparently I shot a GSP. It's kind of good. Wow. Added me on the website, huh? Okay. Nah, thanks for putting me on the website, bro. I'm gonna go ahead and give him my $4 for saying like too many times. Must be $1,000. I don't know about the minimum being $1,000, homie. Dude, kids these days need to support open source projects. Yeah, let's go in Gleam. Search debug. Like if I just want to do here debug debug locked, or sorry, DBG locked. Wait, let me go back to this. Excuse me. I'm here doing DBG lock, and I compile this. So, excuse me, I compile this. Go here. Okay, it does work. Locked. Standard lib. Huh. So Gleam JSON isn't even locked. It's GUI unit. So I think I misunderstand what locked is. Ariatic. Function of indefinite arity. Yeah, that seemed like a bunch of work for no reason. Врач, мне надо помочь. Помочь. Забуду. The single limitation there is that the subset of your runtime errors that don't have their line numbers statically added to them have slightly off line numbers.
And the bytecode. And I chose to target, and you could actually compile to Erlang source. That's what Gleam does, I believe. They actually compile to a textual Erlang file
okay, yeah.
and not AST. But that has like some very big limitations, like your lines are going to be off in stack traces, right? So when you get an exception in Gleam, I believe, like the stack traces, they do not match your actual code.
I haven't checked that.
Which is something that like the JavaScript community, they had to solve those issues. That's why you have things like source maps and so on. So I think those are the 4 options, and we chose the Erlang abstract format because it allows us to have like proper stack traces and everything, proper error messages, but still share as much as possible, as much as possible tooling as Erlang. And the reason we did that at the beginning was because there were like, so Erlang has a tool called Cover, which is for test coverage. And the test coverage maybe changed today, but the test coverage, at least back then, it would analyze the Erlang AST and add annotations for test coverage. And if I didn't target the Erlang AST, I would have to implement my own cover version.
Right, yeah.
There's also a tool called Dialyzer, which is like it's a discrepancy analyzer. It's kind of a type system, not really, but it's aims to find bugs in your Erlang and Elixir code.
Right.
And Dialyzer as well, I believe at the beginning it required the Erlang abstract format. So in order to maximize like the tool, what we could use from Erlang, we chose the Erlang abstract format. But later on, with time, I wanted to have the option of like, well, maybe I want to compile to core Erlang in the future, and then I would be able to do things that I cannot do today. So I would get like a little bit more expressive power. So with time, I actually made a bunch of improvements. I submitted a bunch of improvements to the Erlang compiler tooling. So it allows programming languages to say, like, look, I'm going to keep my own representation of things. And if you want something else, I'm going to give you that something else. So I came up with a contract between programming languages and tools. So we have the flexibility to choose, but we never really ended up like making the change. We still target Erlang abstract format, but we have done work to be able to say, if we want to go lower level in the future, we can as well.
Okay. I suppose one huge advantage to that is just like you were saying with Elixir macros, right? If you know if you've got an intuition for how the syntax of Elixir turns into an AST, you can write macros. I guess you develop the same intuition of, here's the Erlang source code I want to ape. I know what AST that will represent, so I know how to compile it.
Yes, the translation layer is like, it's really straightforward between one and the other. Honestly, the only tricky thing in the whole translation layer is how it's the difference between how Erlang and Elixir, they do variables. Like that's potentially like the biggest difference between the languages. So in Erlang, the variables, they are, you can only assign them once, right? So if you do x equals 1, you cannot do x equals show later, right? And that's good. There's a long blog post I wrote like comparing.
Yeah, that is kind of misleading. That really doesn't occur that much. There's no runtime errors. That's kind of crazy. That's kind of dope. There's no runtime errors. This guy's so goated, dude. Working at Vercel. Just churning up. Just churning out stuff. On Next.js PR. The goat. No, this guy's insane, dude. This guy's so cracked. No, thanks for putting me on the website, bro. I appreciate that, man. Oh, this guy made Bevy? It's kind of dope. It was a Microsoft. He switched to got this guy or this person. What the? Oh hell no! What the hell? That's what he did. Nah, fuck with it. That's wild. That's freaky, bro. This is impressive. I don't know nothing about this, man. It's kind of crazy how big the world is. Just that there's like this many programmers. And even like being at a college, being at like a big college, there's probably a few dozen programmers like this. But there's thousands of them on GitHub. D. So, so locked does not have this one. But if I do this, alright, that just made it resolve. Let's do this. Hmm. What does a locked dependency do? The exact version is explicitly defined. Or is it talking about the locked file that already has a version? That's a good question, because you have this, which is like the literal locked versions. And you have your requirements, so version 1.2. How is the other one not locked? Alright. Probably gonna end this. I think it was largely successful. I gotta get more information about the locked thing. Because the current core compiler is saying that locked is like version constrained to a range and not necessarily version constrained to an exact version using like the tilde arrow thing. So I'll probably look into that. But yeah, I'm gonna end this. Solid 6 hours. And I'll be back tomorrow. You know how it is.